Hey guys, welcome back to week 3. We're going to go over unit 3 on the AP test, which is mostly population studies. I hope you've had a great week and you're enjoying this time off. So here we go. Alright, we're going to start with generalist versus specialist species. A generalist species has a wide diet, it's very adaptive, and so a lot of times they can be invasive species if they're introduced into an area. A specialist species has a selective diet or maybe a behavior like they mate one day a year, which is a thing. And so they are more likely to go extinct. We're going to watch 2 videos. The first one will be over specialist species and the second one over an invasive species.
Some animal species are found in almost every corner of the world. We humans are generalists, for example, using our big brains to find ways to live in lots of different environments. But other animals are isolated from their relatives on islands and mountaintops or tucked away in deep caves. And when a species lives in only one place, whether it's a single lake or a whole continent, we say it's endemic to that area. Over time, these animals can develop special adaptations to their unique habitats, and these 8 have done just that. Each one lives in a very specific spot, and it's really good at living there. Let's start with the Santa Cruz kangaroo rat. It's a small rodent that you can only find in the Santa Cruz sandhills, a small swatch of land in California. Kangaroo rats get their name because they use powerful hind legs to hop around and long tails to stay balanced, like kangaroos do. Of the 23 species of kangaroo rat, these guys are especially suited for the sandy soil and shrub-filled landscape they call home. Santa Cruz kangaroo rats are slow to mature and reproduce, which helps them conserve energy and survive during droughts. But this also makes it harder for populations to recover from threats like habitat loss, which isn't great news for them or the environment. As it turns out, this kangaroo rat is a keystone species, an animal with a big effect on the ecosystem where it lives. In other words, if they disappeared, their habitat would permanently change. See, kangaroo rats make a lot of burrows and bury seeds to eat later, so they're unintentionally helping plant populations grow and stay healthy. In the late 1900s, researchers even ran an experiment where they excluded 3 species of kangaroo rats from small areas of desert shrubland over 10 years. Without these rodents, the regions were converted into much grassier terrain with different plants and animals living nearby. So these critters aren't just endemic to the Santa Cruz sandhills, they're also really important to make sure a bunch of other living things have a sandy, shrubby home.
Invasive species are non-native organisms that cause considerable damage when introduced to a new area. These species compete with native wildlife for resources and thrive at the expense of the local ecosystem. The introduction of invasive species is often associated with human activity. Boats that travel between different bodies of water can carry hitchhikers, such as the zebra mussel. One of the most notorious invasive species in the United States, these rapidly reproducing mussels clog pipes and overtake beaches in the Great Lakes.
Alright, so you saw that a specialist species, in this case, only lived in one place and reserved a lot of energy, which then took away from their ability to reproduce. And then you saw invasive species that they could go different locations, be placed different locations, and then thrive. Okay, so now we'll look at R-selected and K-selected species. And remember, R-selected species are those that they over-reproduce. And they over-reproduce because they know there's a great likelihood of their offspring dying initially. And they understand that very few will survive. And so those are R-selected species. K-selected species are like us. We care for our young, we have few offspring. And so if you look at the chart side by side, you can see the comparison. R-selected being small, and typically K large, and so you can go through the list and write down a few things. All right, so survivorship curves are the next thing that we're going to go over, and you guys made a survivorship curve out of some cemetery data, and so remember that R-selected and K-selected can fall into these as well. And so when we did the human portion of it, it looked like the top one I just colored. So you had a lot of humans living a long time, and then as they got older, they died off, and that's type 1. Type 2, there is an equal chance of death throughout their lifetime. And so you can see I'm drawing a little baby. So we have the person up there on type 1. On type 2, you've got some birds, right? And so at all points of life, um, they're susceptible to predation. Uh, if you look at the type 3, then that's going to be like your R-selected species. They over um, reproduce knowing that a lot will die off. So now we're going to look at age structure diagrams, and this first one is Japan with a declining population, and we know that culturally, well, there are a lot of women in the workplace now, and so we see that they are not having many children, and if they do have children at all, maybe it's one. And so this shows males and females, and you can see what percentage they make up each generation, and that's what each line represents. And so if it's narrow on the bottom, then we know that it's a declining population. Okay, and so here you can see that in the 60s, the United States was still growing, but if you go fast forward 100 years, then we're going to see that we're going to be more stable. And so those are age structure diagrams, growing on the left, stable on the right. And so we're going to keep talking about population growth, and we are going to visit the US Census Bureau, and it has a lot of really interesting stuff. And so if you check it out on the left side, you can see the US population, you can see births and deaths, and a net gain of a person every 20 seconds. And on the right side, you can see the 10 most populous countries. And so China and India are way up there in the billions, and they're really not that far apart. India's catching up, and the United States is at 331 million. All right, so you can see on the left side the regions that are growing, and on the right side you can see from 2010 and to the future how our age structure diagram is changing. And so you can see the boomers going up and down in this image, but you can see that wide portion up top. Pretty cool. All right, and so then you can look, and they also have the most populous states, counties, cities, the highest population density, which remember density is how many people in a given area. And so right here, if you look at the counties, you can see also the population or the population density on the far right. And so there are 27,960 people in New York City per square mile. Wow. All right, so now we're going to talk about population growth in regards to carrying capacity. And so you can see this is it complete, but I'm going to walk through my little drawing coloring thing with you, and so that you can kind of flash back to what we've learned in the past. So here we go. All right, so the biotic potential of a species is without any limitations how much a species can grow. And so it's limitless. The carrying capacity, though, is the realistic, like there are resources needed. So initially, a population grows exponentially, but then there is environmental resistance, or things called limiting factors. Some of those limiting factors are things like disease, space, food, shelter, finding a mate. And so you can see that shows that as well. The logistic growth is just, it stays beneath carrying capacity. So now we're going to look at total fertility rate. And the total fertility rate determines population growth because it's how many children a woman has on average in a specific country. So this chart's pretty cool. It shows how long it took for countries to culturally change, to go from having 6 kids per woman to fewer than 3. And you can see for the United Kingdom, Poland, USA, it took a long time. But for countries like China that mandated the one-child policy, it took 11 years. And the thing is, it takes longer to reverse that, or it may never happen. This is really cool too. It's from the same website, and it shows the children born per woman over time, and you can select different countries. So here's the United States. You can see it's going from the 1800s, and it'll fast forward to current times. So I did add some other countries as well, and so when there is that data present, then it populates, but there's not great data for every single country, and so we'll go through and see that. So there's Rwanda. We started getting data, and so you can see it is pretty high, but it starts to drop. A lot of times that's because of education. All right, so now I'm going to go in and I'm going to put some different countries, check them off, and then you'll be able to see that one as well. And I'll speed up the video so it doesn't take quite as long. Okay, now we're going to look at population growth and resource availability. There's a really cool video from National Geographic that we're going to check out. It has a lot of cool data and visuals. So check it out. All right, so now we are going to talk about demographic transition model, and that's something that we have to talk about for this class. So let's walk through a coloring sheet together. All right, so here you go. You can see that population growth is relative to birth rate and death rate. In the first stage, pre-industrial, there's no industry, no healthcare that's widespread. Females aren't receiving the education, maybe there's no contraceptives. Well, for sure there's not. And so then they transition into transitional, and healthcare is introduced. We see industry is introduced, but it's not widespread. Culture is still keeping that birth rate high. So then once a country gets into industrial, we now have industry and healthcare widespread. There's access to education and contraceptives, and there's a cultural shift. Post-industrial, you end up seeing that women are more career-oriented and that population can actually take a dip. Okay, now that's a cool website. If you're taking the AP test, make sure you go to it. But there are some population equations that you have to know. Here they are. Population density is population over area. Birth rates and death rates, it shows you how to calculate each. But remember, when they use the word crude, it's already been reduced. So it only has to be divided by 10. And we'll do some practice on that this week. And so make sure that you write these down. Remember, doubling time is how many times in years it's going to take a country to double. And so here are your population math problems. More practice to come. All right, you guys have a great rest of your day, and I miss you. I'll talk to you later. Bye.